Hey, hello everyone. I'd like to welcome you to today's Tech Talk on why Jakarta EE matters. I'm Ryan Cuprak, President of the Jakarta EE Ambassadors. You can find me on Twitter at several different places. I also run the Connecticut Java Users Group. A little background on me. As I mentioned, I work in charge of the Jakarta EE Ambassadors. I work for Dassault Systems on chemical formulation software. I run the Connecticut Java Users Group, and I'm also co-author on EJB3 in Action, 2nd edition, and also the NetBeans certification guide. My day job, I work on, as I mentioned, chemical formulation software. If you're kind of curious as to what I do, it's a video that we put together last year on using the software that I work on for formulating hand sanitizer. So if you're curious to learn more about that or see a Java application that's actually used to design things, the software that I work on is used to actually design many of the products that you make, so check it out, and it does use Jakarta EE underneath the hood. So today's presentation, I'll put it into presenter mode. So today's presentation, I'm going to go over basically why Jakarta EE matters. For those of you who might be new to Jakarta EE or joining this for the first time, Jakarta EE is a community and vendor-driven open standard. It was originally named Java EE or J2EE, and you'll commonly see that on job postings, etc. So you'll see, given its long history, they refer to as either Java EE or J2EE. And you often need both of those on a resume in order to get picked up by the resume systems nowadays. It transitioned from Oracle to the Eclipse Foundation in 2018. Originally, it was developed by Sun Microsystems. It is composed of multiple specifications covering messaging, web services, security, WebSockets, JSPs, object relational mapping, mail distributed transactions, etc. It actually covers numerous things. And although many developers think of it as monolithic, it is actually multiple specifications underneath the hood that you can use independently. And I'll kind of cover that as I go through the presentation. There are multiple open source and commercial implementations of it. Specifications include a compatibility test for verifying conformance. So when you're using the different implementations, they actually have to pass a test kit verifying their conformance with the specifications. And as I mentioned, the implementations must support the TCK, must pass the TCK. Jakarta EE has a long history. It was first released in 1999. Applications, as I mentioned, are portable between implementations, and generally it's backward compatible. Although that's changing a little bit right now with the package renaming, which is going on at the moment, which has already happened. And the interesting thing the nice thing with Jakarta EE is applications written in 2001 can still run today. And that can't be said for many technology stacks out there, that you can take an application that was written 20 years ago and still run it today. And that's one of the ideas behind Jakarta EE, or one of the driving forces, is it's a standard. It evolves slowly and doesn't, the objective is to enable you to write applications that you then turn around and make money on and not rewrite every day. Many developers out there, many Java developers out there don't necessarily consider themselves Jakarta EE because they only use a small portion of the specification. So you'll see on resumes somebody's an expert in Hibernate or servlets or web services or messaging. Those are actually all Jakarta EE technologies, and there's no requirement that you use all, that your application uses all of the technologies. So as a result, probably most of the Java developers out there are actually really Jakarta EE developers, as they use Jakarta EE technologies every day to get their jobs done, even if they don't consider themselves, writing applications for an application container. Jakarta EE has evolved over the years. So it started as JPE way back in 1999, and continued to evolve first with servlets, and container managed beans. The real inflection point came around 2005 with Java EE 5, which leveraged annotations, and has continued to evolve further. So back when Jakarta EE or Java EE first came out, SOAP and web services were big. Today, we're seeing things like HTTP2, JSON, WebSockets, etc. So it's continued to evolve as the tech industry has changed, and it's had a relatively regular release cadence. initially it was at the beginning, it was every couple of years, and now hopefully we'll be in a release cycle of every year. So it has continued over the last 20 years to evolve. Now, Jakarta's EE age and perspective. A lot of Java developers kind of look at Jakarta EE sometimes and say that it's kind of an older technology. And while that's true, Jakarta EE is 21 years old. Java is actually 25 years old, and some of the technologies out there like C, which are used for which are still heavily used, are almost 50 years old. So Jakarta EE is relatively young compared to many of the other technologies out there. I mean, for example, Python, which has garnered a lot of interest the last couple of years, is over 30 years old now. So Jakarta EE is not as old as some of the other technologies that are out there, but it does have a pretty long track record. Jakarta EE is made up, as I mentioned, of multiple specifications. These specifications you can, in many cases, use independently of a container, so you can build a standalone application using them, but it's composed of many different features that people work on individually. And just kind of, we've got JSON bindings, we've got APIs or specifications for servlets, enterprise Java beans, messaging, persistence, etc. So it covers the gamut of practically anything an enterprise application would need to do. Some of the more recent evolution of Jakarta EE has included, support for JSON, for example, a JSON pointer, which added support for patching and merging, streaming API for processing large JSON files, etc. Kind of more example code here with working with JSON pointer for pulling data out of a JSON file. Also JSON patch, which allows you to modify parts of a JSON document and make changes to it. More information down below on what a patch is with verbs. And as we can see right here, some example code just making changes to that. And these are some of the more recent things that have been added to Jakarta EE, enabling you to work with JSON coming from the JavaScript world and work with front-end JavaScript applications. So it provides, these are standard APIs that are available in multiple containers, and you can use independently for just running a Java SE application for working with JSON today. So it's, it started out way back in 2000s with a focus on XML, and has continued to evolve and adapt and add support for standardized JSON APIs. This is an example here of using bean validation. Key feature of it allowing you to validate data so that we can, ascertain that if we have a list of email addresses, that they're actually valid addresses. Basically, and these annotations that are going on the methods here, these are standard annotations from Jakarta EE for validating data. So these can be used for validating data that's coming from JSON, coming from web services, coming from a database. So it's really a holistic solution. JSON binding, one of the other new standards, which allows Java bidirectional mapping between Java and JSON, making it easy to get data back and forth. So it provides the default mapping algorithm for converting between Java classes, provides an JAX RS standard way to support application JSON for POJOs, etc. Kind of going to the power of Jakarta EE is that, you can be a standard regular Java developer using JSON-B, which comes from Jakarta EE, in order to get, to work with JSON data. And some JSON mapping example. Okay, so there's too many specifications to cover, but it provides a lot of the core technologies that Java developers use every day for getting their job done. If it's working with JSON data, if it's working with databases, validating data, Jakarta EE has a specification and implementation to help you address those business needs. So what is a Jakarta EE application? I think there's a lot of confusion about this. So many developers, especially developers that have been in the Jakarta EE space a long time, think of monolithic applications first. Those are applications that are running in a container. It might be multiple applications running in a container, but they're monolithic. They're not microservices like microservices application. There are also cloud applications, so applications that are running maybe as AWS Lambda, or some lightweight application up there in the cloud running inside of Tomcat, providing a set of microservices, etc. Those are also Jakarta EE applications. Command line applications, as I mentioned, you can use the specifications to write command lines as well as desktop applications. I've used JPA and CDI to put together small desktop applications. And so that's a valid use of Jakarta EE. Jakarta EE is just not monolithic applications like what developers were writing back in 2002. There's many different, you can take the standards and the implementations and mix and match it to develop your own application. So if you're writing something for like AWS Lambda, you could use a couple of Jakarta EE technologies for processing JSON, for pulling data from a database, and there you go. You're still using Jakarta EE technologies. So Jakarta EE application can be hosted in application containers such as JBoss, Wildfly, etc. It could be hosted in a web container such as Tomcat, Jetty, Java SE application. You could be using CDI, context dependency injection, with JPA for retrieving data from a database, with bean validation in a desktop application, or even a microservice application. Applications can be deployed via standard packaging, such as WAR, EAR, although these days it's mostly WAR packages that are deployed. Those are great for if you're building up Docker containers. You can wrap your application up in a WAR file, and it makes it very simple to deploy it. Application containers range from Pyera Micro, which is a single jar file, which basically you can kind of think of it as a full Jakarta EE application container, something like, full container in a single jar file, and you just pass it in, do java-jar, run it, and give it your WAR file, and your application's up and running. Or WebLogic, WebSphere, which are complex application servers, which can be configured as needed. So with Jakarta EE specifications, you want to map Java objects to relational database. You're going to use something JPA, of which you have Hibernate, Eclipse Link, the Apache OR OpenJPA. If you are implementing RESTful service calls, you're going to use JAX-RS to implement the service, of which you're either going to use Apache CXF, RESTlet, Jersey, etc. And these are all implementations of Jakarta EE, and they have additional features beyond what the specifications provide. So the specifications define the required features, and then the implementations can add additional features, have different performance characteristics, allowing you to pick whichever one you based upon cost and feature set that you would like to use. Jakarta EE specifications, there's specifications for sending mail, for validating data pass for a web service, as we saw before, bean validation, doing dependency injection. Two primary implementations of that are the Weld and Apache Open Web Beans. And all of these specifications can be used standalone. So for example, you can use JAX-RS as standalone to implement web services. You can use the Java Mail API to implement a desktop mail application if you so choose. So all the specifications can be used outside of the container. So there's no requirement that your application be packaged up into a WAR and deployed that way. All implementations of the specifications must pass the TCK. And as I mentioned, implementations can and do have additional features. So for example, Hibernate implements JPA specification, but adds tons of additional features for things like talking to graph databases. Spring Batch implements the batching standard and then adds a bunch of additional features on top of it, giving you a compelling reason for using that. Implementations differ in features, in terms of the features that they offer, licensing, support, and cost. If you code to the specifications, then you're not locked into a particular vendor, so you can easily switch implementations of a standard if you just code to the specification. And coding to the specification gives you, a baseline of how to use, the different implementations. So for web services, if you are familiar with JAX-RS, switching between RESTlet and Apache CXF is not that hard, because they basically work the same. You use the same annotations between the two of them. It allows you to easily transition between different implementations. Java EE transitioned from the JCP to the Eclipse Foundation as Jakarta EE. So originally it was Java EE and has been since now renamed as Jakarta EE. It has an open governance and open source has open governance, it's open source, and has open compatibility tests. It has a well-defined specification process, a clear IPA flow, vendor neutral open source collaboration, and a fairly level playing field for vendors that are looking to get into it. And one of the things I want to stress with this is that community participation is key to its evolution. So if you are a Jakarta EE developer, you're using Hibernate or you're using Spring Batch or something like that, you can get involved with Jakarta EE and drive it forward. Unlike other technology stacks that are proprietary, Jakarta EE enables the end users of the technology to actually get involved and push it forward. So if, there's no, I've heard developers in the past at my Java users group will say, why did Sun do this or why did Oracle do this? When in fact, they can actually get involved and make the changes themselves. If they want to see a specific feature go in a specific direction, it is easy to get involved with Jakarta EE in pushing it forward. And it's actually surprising how few people actually get, given the size of the ecosystem and how many people depend upon it, how few people are actually participating sometimes. So with that being said, main page for Jakarta EE, this is your entry point into the ecosystem for learning about it and for getting involved with the standards. Jakarta EE and open source. Jakarta EE specifications and compatibility tests are open source, as I mentioned. You code against the APIs, not the implementations. And you only use something specific for the implementation if you're after a specific feature for that implementation, right? So if you're using Pyera and you want, to use some additional feature that they've added, you then, depend upon that. But your baseline code is depending against the interface for Jakarta EE, enabling you to easily transition to other implementations or use code that was written for other implementations on your chosen implementation. Some implementations are open source, such as Glassfish, Pyera, Tomee, OpenLiberty, whereas others are commercial, and the commercial ones obviously have different features and things that set them apart. So what you're guaranteed is that they all implement the standards, and then you get to pick which one you want to use depending upon your criteria. Development is controlled via the Jakarta EE specification process. Is vendor neutral and has a level playing field for all participants. It's got policies governing IP flow and ownership around it. And the goal with Jakarta EE is really to maintain continuity and backwards compatibility. So important thing to remember is that it is a standard, and it standardizes things after the industry has decided to basically go in that direction, or multiple people are using that. And it's got currently got a 20-year plus track record of releases. Which is pretty good for technologies, because many technologies don't necessarily last that long. And as I mentioned earlier in the presentation, an application written back in 2002, you can still run on a container today. And it's got a large, diverse ecosystem built on top of it. So this is a slide that I threw together with some of the different implementations of specifications and containers, etc. So all of these are implementations of standards, implementations of the standards that you can leverage. Some of them, like Archillion, are used for testing applications. So there's a complete end-to-end. It's a huge, Jakarta EE is a huge ecosystem. And as I mentioned earlier in the presentation, practically every Java developer out there uses something that is derived or comes from Jakarta EE, either an implementation of one of the specifications, if not a container itself. And for many developers, this comes as a surprise. Did you know that Spring depends on and contributes to Jakarta EE? Spring actually contributes to these specifications, the servlet, the JPA, and the batching. So although many people like to think of Spring as competing with Jakarta EE, it's actually mutual beneficial. Spring is actually involved in the evolution of Jakarta EE and uses many of its technologies. Jakarta EE and MicroProfile. MicroProfile also depends upon Jakarta EE and gives you a separate path for writing microservices, but it depends upon it. And I have a slide and a couple of slides that kind of goes over which technologies MicroProfile pulls in from it. So Jakarta EE is critical to the Java ecosystem and to the cloud. Currently, 25 to 35% of Java applications run on Jakarta EE application servers, those being like WebLogic, Liberty, Pyra, etc. And 70 to 80% of Java applications depend on at least one or more Jakarta EE APIs. And below, we can kind of see a breakdown of the different different server-side technologies, Spring, Jakarta EE, and the percentage within the community. And all of these depend upon on different Jakarta EE specifications. The data for this came from the Jakarta EE developer survey back last year. Jakarta EE versions in production. So for applications that are deploying to a Jakarta EE application server, the bulk of them, at least as of last year, were still in Jakarta EE or Java EE 7, with slightly more than a third on Java EE 8. And many of these are large applications, so they take a little bit longer to port. And I suspect some of the transition issues that people are dealing with are more of the Java 8 to 11 issues that have been slowing things down recently. In terms of Jakarta EE specification usage, 79% of developers out there use JPA, CDI, JAX-RS. So you can kind of see a breakdown of, many applications use, because these don't add up to 100%, use multiple specifications for implementing the application. So they use JPA and JAX-RS, etc. To put together an application. So we can kind of see the breakdown here of the different specification usage. Some of the ones like JSON-P are fairly new, so that's why the usage would be lower. So Jakarta EE adoption, individual specifications can be used without running a container, which is one of the nice features of the standard. So you have many options for deploying applications. So you can pick a single specification and add JSON-P, to example, for your application, or you can run it in a container. And as I mentioned, you can run a full container. There's full containers that are out there now that can be run as just a single jar file. MicroProfile further builds and enhances upon Jakarta EE. So MicroProfile is also an Eclipse Foundation project. It is an open source set of specifications, and it originally started as a push to push Java EE innovation forward. So there was a time when Oracle was kind of evaluating their future and kind of getting walloped by not transitioning to the cloud faster, and they lost a little bit of focus on Java EE at the time. And so MicroProfile was an effort to try to push it forward because it is such a valuable and important piece of every Java developer's toolkit. So there's multiple implementations of MicroProfile. So there's Java EE, Jakarta EE containers that implement MicroProfile, and there are also implementations of MicroProfile which don't run it, that aren't actual Jakarta EE containers. MicroProfile does use a baseline subset of Jakarta EE technologies, that being CDI, JAX-RS, and a couple of others. The current release as of last check was 4. Now, Jakarta EE MicroProfile, there's been some confusion as a relationship between the two of them. They are two independent Eclipse projects. MicroProfile, unlike Jakarta EE, the standards or the individual specifications aren't necessarily standalone, so you can't use them outside of a MicroProfile implementation. Not all Jakarta EE containers support MicroProfile currently, although that's slowly changing. And not all MicroProfile implementations support Jakarta EE, or the full set of Jakarta EE. Will Jakarta EE and MicroProfile merge? Probably not. It doesn't look like so at this point. The release cycles between the two of them, MicroProfile releases 4 times a year or quarterly, or that's been the goal. And Jakarta EE, the goal is hopefully at least once per year. Jakarta EE, of course, will evolve a little bit slowly. MicroProfile has more of the get stuff out there fast and see what succeeds or fails. Whereas Jakarta EE is more focused on standardization. Once something is adopted into Jakarta EE, it's going to be there for a long time. Can Jakarta EE apps use MicroProfile APIs? Yes. Do MicroProfile APIs require microservice architecture? No. So if you are developing a monolithic application and you want to use some MicroProfile features, It doesn't mean that you have to rewrite your application as a microservice in order to leverage them. So the benefits of MicroProfile are it gives you the ability for doing application monitoring, standardized configuration. Standardized configuration, the config API right now is actually in the process of moving over to Jakarta EE. So it's being standardized into Jakarta EE and will be used by Jakarta EE specifications going forward for standardizing configuration. REST documentation, some of the other MicroProfile features are fault tolerance, scalability, service tracing, and security with JWT, Java Web Token. So as I mentioned, MicroProfile, the current release 4.0 release of MicroProfile depends upon Jakarta EE standards, CDI, JSON-P, JAX-RS, and also JSON-B for binding JSON back and forth to Java objects. So just to stress the point, MicroProfile depends upon Jakarta EE and it's at its base. So some of the additional features that MicroProfile adds that Jakarta EE applications can leverage are a unified API for generating Swagger documents and documenting JAX-RS REST endpoints. It's very easy to add this onto an an existing JAX-RS endpoint to add documentation to it, and you end up with your Swagger documents automatically generated. You can also provide Swagger documents, and that will serve them up. Fault tolerance separates execution from execution logic. So this, once again, is tying into web services. You don't have to rewrite your application as a microservice to take advantage of that. If you already have RESTful endpoints, you can add, retry logic, etc., retries and fallbacks, and bulkheads and circuit breakers to your existing JAX-RS web services. So it's meant to be layered on top of it. Health checks provide a way of probing an application to find out how it's doing. So, for example, if you're deploying an application to a Kubernetes cluster and you want to have it use this for determining whether the application is up or down, etc. So the primary target for health checks is something cloud environments where you have some automated process maintaining it. So the health check will, basically say whether the application is up or down and provide some information on its state. The config API, which recently was announced, is moving over to Jakarta EE. This provides standardized configuration for applications. So a way of injecting configurations into an application, so you can, inject, from this example right here, the default client name into an application code, and you can have that configuration being pulled from a database, a properties file, system properties. It gives you several different ways of getting configurations into your application in a standard way of doing that. And so that's why it's being pulled over into Jakarta EE and will be used by standards going forward to provide a standardized way of handling configuration. MicroProfile is used heavily for development of microservices and cloud development, as I mentioned. And also most Jakarta EE containers also do support MicroProfile. So with Jakarta EE and careers, when the technology dies, so can your career. And I've seen this with with developers that they've picked a given technology, they've gone head over heels into it, and then the vendor says, "Oops, we've decided to go in a different direction for whatever reason," or they've gone out of business. So technologies you use determine your career. Often developers are accused of resume-driven development because you can see what's changing, and then you pick technologies based upon what you think the market demand will be going forward. So, you're obviously not going to pick something like DBase for your next project because that's not going to get you any jobs anywhere else. So many Java developers do not consider themselves Jakarta EE developers, but it has provided basically a standard set of technologies that Java developers use and what goes on what they put on the resumes. So even if a Java developer currently does not consider themselves a Jakarta EE developer, their resumes are probably full of, or definitely full of, Jakarta EE acronyms. And I'll have a slide on that in a second, but just to stress, tying yourself to a single vendor is a bad long-term strategy for a developer because vendors change directions on a fairly regular basis. So the nice thing with Jakarta EE and what has provided Java developers over the last 20 years is a consistent set of technologies on which to build your career and which to learn, because they've been around so long, there's applications that are out there. So you can easily move between companies. So you can, if one company is using RESTlet and another one is using Apache CFX, you can easily say, yes, I know JAX-RS, I know how to write web services, and you just need to learn some of the idiosyncrasies of that particular, how to configure that particular implementation. But you can on day one be writing code. It's not something completely new. So it allows developers to easily, move across companies. It enables companies to easily hire developers and know that they know how to write web services, right? Whether they've worked on WebLogic at the previous company, they primarily work with Tomcat, or they're writing microservices. There's a standard set of skills that they will have if they have that, if they list that technology on their resume. So if we look at this example resume that I pulled offline, it's full of Jakarta EE technologies, right? It has the old J2EE because a lot of recruiters, etc., still ask for J2EE and hiring in HR departments. But it's a smorgasbord of every specification coming from Jakarta EE. They don't say at the top of the resume, they say I'm a senior Java developer, but on the resume it lists all Jakarta EE technologies. So Jakarta EE is enabled hiring across the Java EE ecosystem, because if they list it, they know JAX, JPA, they know how to pull data in and out of a database, right? Hibernate, for example, Hibernate's a JPA implementation. So if they know Hibernate, they can work with Eclipse Link. So it's provided continuity for developers out there, and it's provided continuity for companies out there, because companies can easily, a developer knows that the skills that they're learning are going to be transferable to multiple companies, and companies know that they are picking a standard a technology stack which has a developer ecosystem and a set of implementations to choose from that are relatively stable over now 20 years. And just to drive the point home, this is a technology graveyard that I put together of once hot technologies that are now basically dead. So, we've got PowerSoft, if people remember that, Oracle ADF, Web Objects, which were big in the Apple ecosystem. I mean, there were people that built their entire career in companies off of Web Objects, and then, one day Apple decided, nope, we're not going to, it wasn't a standard, we're not going to continue pushing this forward, we're going to drop it as a product. What do you do? I had a recruiter at the Connecticut Java Users Group that was previously an employer. He had based his company and I think a consulting firm off of Microsoft Silverlight. When Microsoft decided, they were going to drop Silverlight, there went his business and there went his career, right? Because it was based upon the vendor technologies. Jakarta EE has enabled developers and companies not to be tied to a specific vendor or a specific technology stack, or a specific implementation. So if you were on Silverlight, now you have to find something else. You have to rewrite your applications as something else, right? You now have a life expectancy on it. And so all of these, I've known people that have based their careers off of each one of these and then ultimately gotten burned. And also with Jakarta EE, just kind of switching gears with the TCKs, the Test Compatibility Kit that allows you to verify different implementations from different vendors. The Test Compatibility Kit is open source, and you can run it yourself. You can even add tests to it. So if you decide that there's some inconsistency, or you want to make sure that you discover that there's a difference between Pyre and WebLib, OpenLiberty or something like that, you can actually augment the TCK. You can run the TCK yourself and verify that. And at the time when I first put together this presentation, there was a new request for the Inforce Suite application for full platform support, and they had submitted their results as a PR. And it was kind of interesting to look through because, you had their PR requesting that they were now a full Jakarta EE implementation. This is a little bit about background on them, and until they submitted this, I actually wasn't familiar with them. But if we look at that, you can actually dive down in and look at the compatibility tests, right? So if you were writing Jacks are, writing RESTful web services, or, in this case, batch services, you can look through the test and you can see that that this is a valid implementation, is passing the test. So you have a pretty high confidence that your code is going to run on this container if you decided to support it, or if you decided to port your application to it. Same thing for WebSockets. And we can see the number of tests here. I mean, there's tests, over 11,000 tests are in this just one subset of the compatibility tests. So these are pretty extensive compatibility test kits. JaxRS has over 2,800. So if you're, moving between different vendors, you have some confidence, you have very good confidence that the other implementations work correctly and that your application will be able to function. So the Jakarta EE's future is very bright. In fact, it's doing very well. Currently, the relationship between Jakarta and MicroProfile is being formalized with the CN4J, which was a recent development. Jakarta EE 9 was released this past December. There was probably the biggest change to applications running on Jakarta EE was the namespace change. That doesn't mean that you have to completely port your application, because containers are free to support both the new and the old namespace, and old applications will continue to run on containers. So there's no feature change with that, with the 9 release. The goal was just to simplify the namespace transitions for applications that are doing that at this time. Containers, as I mentioned, can support the older namespace, so they can run, a Jakarta EE application, EE 8 application, if the container so chooses to support that. Jakarta EE 9.1, I think, is coming out shortly if it hasn't already, with Java 11 support. There's no other changes other than that. And right now, planning is going on for Jakarta EE 10, and you can get involved with that for, adding, for specifying what features you'd like to see added to it. But its future is bright because it's successfully pulled off multiple transitions over its lifetime, right? So Jakarta Java EE at the time, survived the transition from Sun to Oracle, which kind of concentrated power in Oracle. It was successfully open sourced using the Eclipse Foundation, and has Oracle and all of the companies that were behind it back then are still behind it today. And the release cycle is moving forward. And there's been some fairly big changes in the Java ecosystem. I mean, Java 8 to Java 9, the jump to Java 11 is a big transition that many other technologies or other technology stacks probably wouldn't have survived this type of transition. So these are fairly major changes that are going on here, and they're being pulled off successfully. And it's got an active community pushing it forward. So going forward, features that will be added, or looking at being added to it, is more alignment with CDI, adding in support for asynchronous pulling stuff out of like the EJB specification, adding in support for message listeners. Java SE alignment, adding in completable future and concurrency, improving Bootstrap APIs, decoupling the TCKs and modularization. So, for example, taking advantage of like Java EE, the modularization support that was added in Java 9, closing some of the standardization gaps on security, batch and concurrency, persistence transactions. Adding in standardizing things that weren't standardized in the first go around, and it's become obvious that they need to be updated or extended. And then some innovations, support for NoSQL configuration, which is now in the process of being moved over. And so, for example, these are some of the kind of going over some of the proposals, but modernize messaging, so that all we have to do is add an annotation to a POJO class to make it a message listener. Adding in support for standalone Bootstrap API, Kafka interoperability. So these are things that are being discussed for Jakarta EE 10, and reasons for getting involved. So developers are really can, the community can really drive this forward. So if you're an employer or you're working with something and you're saying, well, geez, I wish it did this, or this needs to be standardized because, I look at, there's like 10 different ways of doing this depending upon, which vendor I use, then, and everybody's trying to do the same thing, then that's something that should be standardized. Also looking at being standard, making it into Jakarta EE 10 is support for NoSQL. standardizing NoSQL database access. Now that NoSQL databases have been around for quite a while, so some of the different JPA implementations do support NoSQL, and so this is basically just standardizing how they will work, so that everyone has a common understanding as to how the APIs work. Applications can be built going against the standard, so that they can easily work with different different NoSQL database sources, and have them behave the same way. It's kind of like what JDBC gives us, originally gave Java. And then externalizing bean validation and configuration. So this is an example. And this one, NoSQL, is pretty far along, so you can actually play with this today to see what's going on and decide whether you'd like to see changes made to it, whether it's meeting your needs or not. Security is another aspect that's being tackled. So modernizing the roles allowed and run as, adding in support for OAuth, OpenID, and JWT support. Now, many of these containers already support these, so what's actually being done is standardizing it so that all of the containers have support for it, and that the support is uniform across all of the containers. So that being Jakarta EE, is just to stress, is a standard. So it's trying to, after everyone has said, okay, JWT is the way to go, let's standardize how this works with your Java application, so that you're not dealing with different implementations, different idiosyncrasies, and different versions of those implementations. So kind of some examples of what's being discussed for Jakarta EE 10 for security, being able to add annotations for defining your open identity store definition, etc. And then beyond Jakarta EE 10, persistence alignment with Java SE records. So the language, Java language is now evolving more rapidly. So aligning the persistence with the Java record support that was added in Java, adding in support for JSON schema, more reactive support to servlets and persistence, and making modularity embedded and improving upon modularity and leveraging the modularity changes that were added in Java SE 9. So those are some of the things that are looking forward. So there's discussions right now of what's going to go into Jakarta EE 10, now that 9.1 is basically out, and then further down the road, what's going to happen with Java EE 11, etc. So it is moving forward, and there's discussions about what's going on in the future. Over at the Jakarta EE Ambassadors, we had put together a Google Doc, trying to poll and get people from the community to say what they would like to see involved in that. So we've been working on a document that members can jump in and say, well, this needs to be addressed. I'd like to see this added to messaging, or these changes to it. So just to stress the point that this is something that Jakarta EE is very relevant, because developers can get involved and drive it forward. So you're not dependent upon a corporation and say, a single manager or executive deciding which way it's going to go. It's still it's community driven, allowing the end developers to drive it forward. And there's multiple implementations of that. So there's a very rich ecosystem and exchange of ideas going on. So at least 80% of Java applications use a Jakarta EE API of some sort, and I actually kind of think that's kind of under, because practically everything, unless you're writing a pure desktop application that's not using web services or anything else, that's about the only way that you would not be using a Java Jakarta EE technology. Underpins many of the frameworks and libraries and applications. So whether you're using Spring or MicroProfile, both of those depend upon Jakarta EE. It differentiates Java from other languages. So having this standard API toolkit with multiple implementations, this is very different from what you see in other languages and in other ecosystems. You don't see this where you have a standard way of implementing web services and then multiple implementations of that giving you different features, right? So if you're over in the JavaScript ecosystem, you'll have, there's different frameworks for doing that, but they're not implementing a standard. So you're either using this framework or that framework, right? In the Jakarta EE, you have a standard way of, of working with these, and the technologies are meant to work together. So for example, if you're writing a RESTful web service, the bean validation framework works with it, right? There's tests that verify that they work. You can use bean validation with JAX-RS so that your Java code, when the web service hands you a Java object that's been inflated from JSON, it's determined to be valid. Other ecosystems, you're kind of like gluing things together yourself. So it might not glue together very well. There might be holes that you're not aware of. So you can use the different pieces of Jakarta EE can be used independently. However, they are tested together and they're meant to work together. So as your application needs evolve, you can continue to build upon that. And it's guarantees to be backwards compatibility. So that ties into the business. So it enables you to minimize vendor lock-in. It simplifies your hiring process because you have known skills that you're hiring for. Because if you hire somebody, and for some of the other languages, the different toolkits are very different. An Objective-C developer and a Swift developer, those are two different, you need to hire somebody that writes a iOS application. If you have somebody that's in front of you that's a Swift or an Objective-C developer, those are two completely different technology stacks. So it provides long-term continuity and stability. Write once, not rewrite every year. So the objective is that you write your application and you make money off of it and you add additional features to it. You're not just getting thrashed by the ecosystem as somebody updates something in a library, and is used widely in the cloud and has many solutions. And I think that Jakarta EE with the cloud vendors right now all would prefer that you get locked into their ecosystems. And the idea behind Jakarta EE is that there's a standard set of APIs so that your application doesn't get held hostage to a particular vendor, right? Or a particular, ecosystem. And on the career side, it provides career stability and transferable skills and an alphabet soup used for hiring. So some common Jakarta EE misconceptions. Jakarta EE, Java EE requires you to use JSP, servlets, JSF. The answer to that is no. If you're writing a Jakarta EE application, you can do your UI using Angular, React. There's nothing that stops you from, there's no requirement that you use JSF. JSF, came out of, solves a particular problem and came out during, a specific time period. It's a standard. Applications that were written with it 20 years ago, or 15 plus years ago, still run today, right? So if you have an application that was written with it, you don't have to rewrite it every time things change. If the application was, written for some internal payroll purposes or something like that, you don't have to change it. It still works. However, if you're starting development today, you do your back end with JAX-RS and a React front end. Jakarta EE are for monolithic applications. No, that's definitely not a requirement. Jakarta EE applications can be, microservices. They can be Java desktop applications. You can mix and match the standards to implement whatever you need to do. So if you're trying to process JSON data, it's better to use an implementation from Jakarta EE because it's been tested. It's been examined for performance. It's got regression tests on it, and it's got, it'll be backwards compatible. So a year from now, it'll still work. You don't have to worry about something changing. I've seen developers go off and try to implement, not use Jakarta EE technologies and try to implement their own JSON, serializers and deserializers and stuff like that. And that's, not directly relevant to what they were actually trying to implement. Jakarta EE is stagnant. That's definitely not the case. It is moving forward. There was a slow year with the transitions with Oracle to the Eclipse Foundation, but that's been completed, and that was a major hurdle that required a heavy investment from Oracle and Oracle's legal group to pull off. And so many other technologies, they would just if it was not valuable or it would be put out to die, and that was not the case with Jakarta EE. A heavy investment was made to get it donated to the Eclipse Foundation to push it forward. And Jakarta EE is an all or nothing. No, that's definitely not true. I've been making that point throughout the presentation that you can use mix and match the technologies from Jakarta EE to build whatever type of application you're trying to construct. If you're looking for some demo applications for Jakarta EE, Cargo Tracker, which just actually recently had a release, is a good one that uses many of the Jakarta EE technologies and provides a roadmap for how to use different ones. I've also put together a simple Jakarta EE starter application, which includes built-in integration tests. It's basically just a hello world, but the Maven file is all set up so that you can clone the project and you're off and running. Because that's going to be a bit of a hurdle. And so ways of contributing to Jakarta EE, so you can follow the Jakarta EE technologies that interest you on the mailing lists. You can advocate for specific changes to projects, and you're community. It's really community driven, so individual developers can get involved. Sign the contributor agreement and then get involved on the different standards, or engage a Jakarta EE ambassador. We gladly redirect. Our role as Jakarta EE ambassadors is to try to help developers get involved and push Jakarta EE forward. So some more resources, so the mailing lists, the Twitter handle for following up, and of course Jakarta EE Tech Talks, which you're watching today. So that's the end of my presentation, which I'm used to presenting in front of an audience, so I think I blew through this pretty fast. So are there any questions?
Yeah, thank you, Ryan. We had one question come in from Mahid. He asks, or they ask, could we use JTA to connect NoSQL?
That's a good question. I actually don't know the answer to that off my top of my head. I haven't actually played that much with the NoSQL specification.
Understood, no problem.
But if he drops me a line afterwards, I can try to help him get an answer to that question. Yeah,
definitely. And at this point, we don't have any more questions, but what I'm going to do is give people a little more time to get them in. There's been a lot of information here and a lot to cover. So if you have questions, please feel free to ask them in the chat or using the Ask a Question tab. But at this point, I will just give some quick reminders of upcoming news in the Jakarta EE community, and then feel free to get in your questions and we can address them after that. So the next Jakarta Tech Talk happens on June 2nd. Chris Walker and Greg Wilkins will join us to present Eclipse Jetty for Servlet. If you're interested in learning more about Eclipse Jetty, you can register using the link I just posted in the chat. There are also only 2 weeks left to submit a response for the Jakarta EE Developer Survey. This survey helps Java ecosystem stakeholders better understand requirements, priorities, and perceptions of enterprise Java communities. If you fill out the survey using the link in the chat that I'm about to post, you can sign up and win some free Jakarta EE swag as well. Third, we're always looking for more tech talks. So if you're working on a cloud-native project that you would like to present to the community, you can sign up today using the third link. And finally, if you have any feedback on how you enjoyed this presentation or what we can do better, by all means, fill out the post-event survey. We had another question come in here. The question is, should one focus on one specific container or implementation to be fully involved with Jakarta EE, or should one just stick and focus on the APIs?
For involvement, I would focus on the APIs. So if you're looking at getting involved, the way is through contributing to a specification. Now, if you're, so that's for getting involved for pushing it forward. Now, for actually, getting your day job done, you probably heavily invest in a given container or a given implementation because you're picking it for the features that it provides you, the additional features. So it's kind of, yes, I mean, I know I focus heavily on one particular, or actually two particular Jakarta EE implementations on my job. But then, I try to dive deep into some of the individual specifications that I'm interested in, or that I have to, use a lot.
Makes sense. And then another question from Adrian. They ask, could you tell us more about Jakarta EE Starter? I think you mentioned and demoed it in the integration tests.
Yeah, so that's just a simple
Sorry, everyone. It looks like we may have lost Ryan. I'm not sure if he is still with us. We will see if we can get him back, and hopefully we can get that question answered. All right, it looks like we are struggling to get Ryan back, but that's okay. Just one question outstanding. Thank you, everybody, for joining us today. And then we hope to see you at the next Jakarta Tech Talk. Take care.